At present, researchers are constrained to rely on these intriguing but limited insights into the characteristics that lie in store on the external facade. In a fresh depiction, a majestic pyramid-like summit looms over a comparably level expanse, creating a striking contrast in elevation across the scene. The uniqueness of the mountain sets it apart in a distinctive manner, exhibiting characteristics that are uncommon in the nearby vicinity and scarce across the entirety of the dwarf planet. This mountain stands out not only for its physical features, but also for its geological and topographical attributes. The framework is believed to ascend approximately 3 miles. This comparison serves to illustrate the considerable elevation of the structure. The next image provides a more intricate depiction of the bright spots. Numerous smaller bright spots are visible surrounding the main prominent area, which is roughly calculated to span 6 miles in width. This closer examination offers a deeper insight into the distribution and characteristics of these luminous features. Ice and salt are the primary hypotheses that researchers have put forward to explain the peculiar reflectivity observed in this context. Dr. Mark Raymond, the mission director and chief engineer of Dawn, expressed his enthusiasm at the sight of these features becoming more distinct. Upon embarking on its observation of a distant location a few months back, Dawn was initially dubbed as a singular bright spot. However, with the explorers' gradual approach and improved vantage points, it became apparent that there were actually 2 distinct bright spots present. This discovery underscores the intricate nature of the celestial body that Dawn is investigating, shedding light on the complexities and nuances that exist within this captivating environment. In the current observation, it is apparent that the phenomenon under scrutiny is multifaceted and complex. The exact reason behind the occurrence of these intense reflections remains unclear, indicating the necessity for further data collection and analysis to shed light on the situation. In the realm of theories, each individual harbors their distinct personal favorite, yet nature stands as the ultimate judge. While we may all indulge in speculation and present compelling arguments, the unequivocal truth will inevitably reveal itself in due time. The diversity of perspectives and opinions among individuals is a testament to the intricate tapestry of thoughts that exists within society. In an in-depth analysis, the probable explanation points towards the residuals resulting from the sublimated ice. The residual salts that remain after this process might be the causative factor for the observed light reflection. The additional visual representations provide a glimpse into the extensive array of craters and intricate lines that adorn the terrain of this celestial body situated within the asteroid belt, the orbits between Mars and Jupiter. There are indications of previous events occurring on the surface, such as movements, soil shifts, and the deterioration of natural formations. Ceres, the largest object in the asteroid belt, was initially classified as a planet. Ceres was later reclassified as an asteroid and finally designated as a dwarf planet by the International Astronomical Union in 2006, alongside Pluto and other celestial bodies that share similar characteristics. Despite its diminutive size, Ceres is approximately 940 kilometers or 585 miles in diameter, making it smaller than Earth's moon. This dwarf planet boasts a wealth of geological features that rival those of larger worlds. Its surface is marked by impact craters, mountain ranges, and mysterious bright spots that hint at geological activity beneath its icy crust. One of the most prominent features of Ceres is a large crater named Okator, which is home to a series of bright, reflective deposits that scientists believe may be composed of salts left behind by sublimating water ice. The presence of water ice on Ceres has profound implications for our understanding of the dwarf planet's history and potential habitability. Water is a key ingredient for life as we know it, and its presence on Ceres suggests that the dwarf planet may have once harbored conditions conducive to the emergence of life. Moreover, recent observations by NASA's Dawn spacecraft have revealed evidence of organic molecules on Ceres, further bolstering the case for its astrobiological potential. In addition to its geological features, Ceres also possesses a tenuous atmosphere composed primarily of water vapor, which is continually replenished by sublimation from its icy surface. This thin atmosphere, while far less substantial than those of Earth or Mars, plays a crucial role in shaping the dwarf planet's surface and regulating its climate. Understanding the dynamics of Ceres's atmosphere is essential for unraveling the mysteries of its geology and assessing its potential as a destination for future exploration and colonization. The exploration of Ceres has been facilitated by NASA's Dawn spacecraft, which arrived at the dwarf planet in March 2015 after a journey of more than 7 years. Over the course of its mission, Dawn has provided unprecedented insights into the geological and chemical composition of Ceres, mapping its surface in exquisite detail and capturing stunning images of its diverse terrain. Among Dawn's most significant discoveries is the presence of bright, salty deposits in Ocata crater, which scientists believe may be evidence of a subsurface reservoir of briny water.
Astrophysicist discovers numerous multiple star systems with exoplanets. The search for life outside of Earth is so relentless because there are so many possibilities beyond our own solar system. In fact, there are thousands of other stars besides our Sun with planets in orbit around it, including more than 4,000 exoplanets. This number greatly increases the odds of finding extraterrestrial life, and it seems that the number of exoplanets is only growing. Dr. Marcus Muggrauer, an astrophysicist with Friedrich Schiller University Jena, has recently discovered and characterized several previously unknown star systems containing exoplanets, and his published study has sent waves through the astronomical community. To obtain these results, Muggrauer searched through 1,300 host star systems in the search for hidden companion stars associated with the host star. He explained his process by saying, "Multiple star systems are very common in our Milky Way. If such systems include planets, they are of particular interest to astrophysics, because the planetary systems in them can differ from our solar system in fundamental ways." Essentially, Muggrauer was searching for the vicinity of thousands of already known host stars in the hopes that they would have an associated companion star that also had orbiting exoplanets. He used the Gaia Space Telescope operated by the European Space Agency in his search, which ultimately turned up fascinating results due to the precise data that he was able to collect. Muggrauer's search revealed the previously hidden existence of over 200 companion stars. The data that he collected allowed him to precisely categorize these new discoveries, which spanned a wide variety as to type and distance. Most of the companion stars varied considerably in their mass, temperature, and evolutionary stage, and some were located up to 1,600 light-years away from the Sun. The team also discovered that, although most of the study's star systems with associated exoplanets were two-star systems, there were a significant amount that were arranged in a hierarchical triple-star system, and even one that appeared to be a quadruple star system. The distance that these companion stars are from each other was also heavily studied, as they could tell us information about how planets are formed under different gravitational influences. They discovered that, of the distances investigated, 15% of stars have at least one companion star, which is a much lower frequency than expected. These companion stars are also up to 5 times further apart than normal systems. Muggrauer says, "These two factors taken together could indicate that the influence of several stars in a star system disrupts the process of planet formation as well as the further development of their orbits. In addition, we will combine the results with those of an international observational campaign, which we are currently conducting on the same topic at the Perennial Observatory of the European Southern Observatory in Chile. We will then be able to investigate the precise influence of stellar multiplicity on the formation and development of planets. One thing is for sure, this astonishing discovery is sure to lead to even more discoveries about the universe in the very near future." A 13.5 billion-year-old star. A new discovery has given scientists a reason to rethink what they thought they knew about our galaxy. The discovery in question is a star called 2-mass J 1808-2002-51043778b. Is believed to be around 13.5 billion years old. If this is the case, the star would have been born only slightly after the Big Bang. Surprisingly, the star is also relatively close to us. This new discovery has made scientists wonder if the galaxy is perhaps older than they previously thought. According to the study's lead author and Johns Hopkins University astronomer Kevin Schlaufman, This star is maybe 1 in 10 million. It tells us something very important about the first generation of stars. There are other surprising things about this star besides its very existence. For one, the star is quite small, as it is just 14% of our Sun's mass. For a long time, researchers assumed that small stars would not have formed during the beginning of the universe. They also believed they would be impossible to observe because they would have faded out by now. As time passed, simulations pointed to the possibility of old low-mass stars. Low-mass stars can live far longer than massive stars. For example, red dwarfs, which are only a fraction of the size of our Sun, are believed to be able to live for trillions of years. Additionally, while most metal-poor stars orbit away from the galactic plane in the Milky Way, this star remains in the plane along with our Sun. Scientists have always been fascinated by stars that are short of metal because they are thought to have formed shortly after the Big Bang, just like this newly discovered star. While scientists have only found a handful of very old stars, they hope this finding begins an era of more discoveries. According to Schlaufman, if our inference is correct, then low-mass stars that have a composition exclusively the outcome of the Big Bang can exist. Even though we have not yet found an object like that in our galaxy, it can exist. As scientists gather more data and discoveries, we hope to learn more about the origin of life.
Solar tornadoes captured on the Sun's surface. Since the Sun is so incredibly important to life on Earth, it is under constant surveillance by scientists, and because of this, you might think that surprising occurrences would be rare. But the invisible magnetic field that bends the charged gas and plasma around the Sun has revealed some strange phenomenon. The Solar Dynamics Observatory, or SDO, is run by NASA and is used to capture high-definition images of the Sun from space. The surface of the Sun is always bending and twisting from the magnetic energy generated on its surface, but recently scientists have noticed an odd phenomenon that appears to be a gigantic solar tornado rotating across the surface. The plasma, which usually flares and spits from the surface with no apparent pattern, was rotating and spinning in a manner that greatly resembles how the debris and trash swirls in a tornado. This supports the theory that the field around the Sun generates solar weather by creating unevenly heated and charged particles that cause currents and other examples of atmospheric variability. These solar tornadoes are not common. Only a few a year are recorded, but when they do occur, they are impressive to behold. In 2015, a gigantic plume of swirling superheated plasma raged across the surface of the Sun for 40 hours, and every minute of it was recorded and analysed by the Solar Dynamics Observatory spacecraft technology. The temperature of the ultraviolet plasma peaked at over 2.8 million degrees Celsius. In 2014, one of these mammoth solar tornadoes spun so violently it spun off the surface of the Sun and dissipated into space. One of the largest recorded solar tornadoes was documented in 2011 by the Solar Dynamics Observatory to be about 5 times the size of the Earth and spinning at a rate of 186,000 miles per hour. The solar flares travelled in a twisting, spiralling pattern up off the surface of the Sun to about 200,000 kilometers into the solar atmosphere. Analysis of solar tornadoes is important because they are driven by the powerful magnetic field of the Sun and usually occur at the same time as massive blasts of solar plasma called coronal mass ejections. It isn't known whether solar tornadoes trigger coronal mass ejections, only that they generally occur in conjunction with each other. But studying the solar tornadoes could likely give us a better understanding of the coronal mass ejections, which are known to disrupt our lives on planet Earth by interfering with GPS signals, radio communications, and power grids. The Solar Dynamics Observatory is part of a highly funded NASA initiative called Living with a Star that seeks to gain a greater understanding of our Sun and the effects of solar variability and weather patterns on our planetary life through the study of such phenomena as these solar tornadoes.